Hi, this is Will Durfee, and I'd like to go over some Creo tips for how to do the center of mass design bonus problem. This is a problem where you've got the system shown in the screen where there is a base that's made out of ABS plastic. There's a beam that's made out of ABS plastic. There's a block attached to the left side of the beam that's made out of aluminum. And then there's another block on the right side of the beam that's made out of steel. Your task is to determine where to position this right-hand block so that the balanced beam balances perfectly on the base. One of the first things you need to do is to assign the right density and the right material to each part. This is the base part that I've opened, and it has to be a material, ABS plastic, which has a density of 0.038 pounds per cubic inches. There's a number of different ways to assign a material or assign a density to the part. So for example, you go to the analysis, click on mass properties, and then you can enter the density right here in the density window. Another way that you can assign a density is to go to File and then Prepare and then Model Properties, and you'll see that a mass properties entry appears, and you can click Change, and then a dialog box comes up and you can enter the density. The way that I like to do it is if you go to the part and then right click, you'll see an Edit Materials. Up will come up a Edit Materials box, and you'll see that you've got some options for particular materials to put in. If you double click this Standard Materials Granted Design, you'll see selections of composites, ferrous metals, plastic, woods. Because the base is ABS plastic, open up Plastics, and there's ABS. So if I double click ABS, then it's got a density in the that's already built in, and then down at the bottom it shows that ABS is assigned to this part, and then I can click OK. Now when I go into the mass properties, you'll see that the density that I've entered from the material assignment is already in. One advantage of doing the Edit Materials is not only is the right density put in, but also other material properties for further analysis, for example, Young's modulus and some thermal properties. So I encourage you, when possible, to put in the entire material rather than just the density. Now, the materials that are listed are limited. This is a sample set of materials that come with the student version of Pro-E, and you can see that, for example, in the ferrous metals there is steel, and the low carbon steel is one that you'll be assigning to the steel block. And then there's non-ferrous metals, and the aluminum rod is one that you'll be assigning to the aluminum block. And then there's others. There's wood, a few woods, but it's not a complete set of materials. In your actual designs, if you've got a specific material, then you've got a couple options. If you just are interested in the weight, say for example your robot in the balance point, you can just type in the density of that material that you have, or you can go ahead and you can add new materials into a custom library. I'm just going to go back, and then once you assign the material, you want to save the part. I'm going to go back in and reassign the density of this to 1.0, because I just want to show you some things where I haven't assigned densities to any of the parts, and to go on to the next part to show you how to compute the center of mass of the various parts. So to unassign material, I've got my material box open again, and then if you right click on the material and then either do unassign, or I'm going to do delete, and then click OK. That deletes that material. And then you can go into mass properties, and I'm going to reassign it back to a density. The default density of all parts is 1. On the screen I have the subassembly that's got the beam, the plastic beam, and the aluminum block at the left and the steel block at the right, because when computing the center of mass, it's this beam and the two blocks that I want to balance on the base. So the density of the base and the center of mass of the base doesn't matter, but the center of mass of this assembly does. So here's how you can find out where the center of mass is on this assembly. Before I do that, let me show the plane displays. And one of the things you want to confirm is if I hover over the right hand side, this is the right plane, datum plane of the assembly, because the center of mass computations for the assembly are with respect to these datum planes. And I set up the assembly so that everything, the beam is centered on this assembly datum plane. So that means that the numbers that come up with the center of mass are with respect to the midpoint. Okay, so that was just confirmation. I'll turn off the planes. Now I go into analysis and then mass properties, and up comes the mass properties box. Click preview, and a number of things come up in the box. So let's just make it a little bit bigger. So one of the things we see is the total mass of the entire assembly. So this is the weight of the assembly. And then if you look at center of gravity, it's got XYZ components. Just highlight them here. It's the X component that we're interested in. That's the left-right component. So right now it says that it is 0.733 to the right of the midpoint. And if you look back, it does make sense because all of these blocks, they haven't been assigned their right material masses. They all have a density of 1, and the right-hand block is bigger than the left-hand block, so you expect the center of mass to be a little bit to the right. And then right now, the beam weighs as much as the blocks because I haven't assigned the right materials, so the beam is going to have an impact in where that center of mass is. Then if I just scroll down, I can see the mass properties of the components. So the beam has a mass of 1, the aluminum block has a mass of 1, the steel block has a mass of 1. So again, you want to go in and assign the right material properties to it before you go ahead and look at where the actual center of mass is for the assembly that's got the right materials to it. So here's how you would iterate on positioning the right-hand block so everything is balanced. If you double-click on the right-hand block, you'll see at the bottom is the assembly constraint, because this block it's been constrained to sit on the beam. It's been constrained so that it is centered front to back on the beam, but then its position with respect of the center of the block with respect to the right-hand side of the beam is a distance constraint. Right now it appears as 1, so if I wanted to move the block to the left, I could say move it to 4, and then I need to regenerate the assembly, so you can go up to Model and click Regenerate, but instead I'm just going to hit Control G. That regenerates it. So now that block is 4 inches, the center of the block 4 inches from the right hand side of the beam. Now if I go back up to Analysis, Mass Properties, in Preview, I see that the center of gravity is now, the X component is now minus 0.5 inches from the center point. So now if we go take a look at the beam, now because the right hand block is closer to the middle, the left hand block is way over here, the whole center of mass has gone to the left of center. So you can imagine that you could iterate back and forth on this until you get to a completely balanced assembly. Another way of doing this problem, because the shapes are relatively simple and might be a little bit faster, is to compute by hand where the position of this center of this right-hand block should be in order that the beam is balanced. And then go ahead and put that position into Creo by adjusting this number, changing it from 4 to wherever it should be, and then confirming that the center of mass is 0. But again, what you want to do is to assign the right material properties, so you're finding the center of the mass for a beam that's made out of acrylic, a beam that's made out of ABS plastic, the left-hand block that's made out of aluminum, and the right-hand block that's made out of steel. I hope that gives you a little bit of guidance for how to go through and tackle this design problem.